do the third question for the day and the last one. Through this, we'll explain the concept of prime and composite numbers. I'm sure you must have all studied this in your primary classes, but this will give you an edge over others when you're able to understand why do we name them as prime numbers and why do we name them as composite numbers. So let's learn that through, again, a question. So you have the following statements in respect of the two natural numbers, P and Q, such that P is a prime number and Q is a composite number. So these are the three statements before you. P into Q can be an odd number. Q by P can be a prime number. And P plus Q can be a prime number again. Now, which of the above statements are correct? So these are the four options before you, 1 and 2, or 2 and 3, or 1 and 3, and it could be 1, 2, and 3. All three statements are correct. Now, very important thing you need to understand is P is a prime number, Q is a composite number, and P and Q are any two natural numbers. What are natural numbers? They are 1, 2, 3, and so on. Now, there has been a very interesting point in this question, which is the use of this word can be. Word can be. We need to be that's what I just told you. You need to comprehend the question absolutely rightly because this is pure logic. You don't have to do anything. Just read the question very carefully. It says that P into Q can be an odd number. Q by P can be a prime number, or P plus Q can be a prime number again. How do you interpret the word can be? So it actually means it may or may not be. So when it says that it can be an odd number, it means that it can also be odd. It could be even, it can also be odd. So we need to find which of the statements are correct. So the only thing you need to understand is the use of the words can be. So these are the three statements before you. Now let's understand what do we mean by prime numbers. So prime numbers are the numbers that have no factors except 1. That means they just have two factors, 1 and the number itself. And what does that mean? They can only be split into equal parts of 1. For example, if I talk about the number 3, how do you see number 3? Now you should be able to visualize it. It can be just split in equal parts of 1. So the word equal is very important. So the number 3 can be split into equal parts of 1. And how do we write down the factors? It is always using multiplication. So we can write down 3 as 3 times 1. Now let us, because I just told you that the word equal is important, let's try to see 2 as a part of 3. How do you write down 3 then? How do you visualize 3? If I take 2 as a part of 3, that's 1 times 2 plus 1, that will give you 3. So what am I doing here is, I'm trying to factor 3 as 2 and 1 or 1 and 2. So are these equal? They're not. We want to stress on the fact that it can be only in parts, in equal parts. 3 should be only in equal parts. These are not equal. And we all know equal parts of things have many special usages. And that is why we are not continuing with 2 as a part of 3. It's just 1 could be a part of 3. Only in equal parts of 1. This is all what we know for prime factors, primes. Let's understand composite numbers. Just the opposite of prime numbers are the composite numbers, in the sense that they have more than one equal parts. They have more than one equal parts. And that means they are made of different sizes of equal groups. They're made of different sizes of equal groups. For example, if I take the number 6, now 6 can be split as 2 groups of 3 each, or it could be split as 3 groups of 2 each, or it could be split as 6 groups of 1 each, or just 1 group which consists of all these 6. So these are the ways in which 6 can be split as. So the usage of the word equal is very important. However, that was not possible in the case of the number 3. In that case, it could be just split as equal parts of 1. And what is the relationship of prime and composite numbers? So the first thing which comes your way to understand prime numbers is that it is just synonymous to Prime Minister. Why do we name him as the Prime Minister? Because he's among the Council of Ministers, the first or the most important person. So first among equals. He's the most important minister. That is why we name him as the Prime Minister. And for the same reason, we name prime numbers, because they are the most important of all the numbers. And you can see for yourself that 2, 3, 5, and 7 are the primes among the first 10. And all the non-prime numbers are called the composite numbers. Composite, why composite? Because they're composed of prime numbers. So every number has only one set of prime factors. They are unique in itself. So 6 can be just written as product of the primes as 2 times 3. 10 can be written as 2 into 5. That's unique in itself. When I talk of 2 into 2 into 3 into 3, that means the unique representation is only for 36 and so on. So they are unique in itself. The prime factorizations are unique for all the numerals. Okay, let's get back to that question now. Again, so this use of can be makes it very interesting to solve the question. So we just have to find one example of each condition to be correct. So let's examine the first statement, which states that P into Q can be an odd number. Now, we don't need to prove it for every P and for every Q. If we get one sufficient example, we'll be done. So if I take P as 3 and Q as 9, then 3 is prime and 9 is a composite number. Their product is 27, which is odd. So the first statement is correct. Let us examine the second statement. It's Q by P can be a prime number. Again, we just need to find out 2 such numbers, Q and P. Obviously, the conditions are given to you that P is a prime number and Q is a composite number, such that Q by P can be a prime number. So think for yourself. If I take Q to be 9 and P to be 3, I get Q by P as 3, which is a prime number. So the second statement is correct too. And let's examine the third statement. There, P plus Q I hope the screen is visible now. Let's get to the third statement, where P plus Q can be a prime number. So we can choose P to be 2 and Q to be 9, where the sum is 11 and 11 is a prime number. So all the three statements are correct. And you can check the correct option now.